Hello, YouTubers and fellow hams. Well, we have a return visitor to the bench. This is a Henry Tempo 1. Quite a while back, I did a video where I repaired this operate, receive, and calibrate switch, which was very intermittent. When you move it to operate, you had to kind of move it about halfway, and we cleaned that switch up. The owner says that recently he turned it on, and he didn't have any audio, no receive audio at all. He said he tried plugging in headphones and didn't make a difference. And so he brought it over to me with that issue, no receive audio. So we're going to power it up. I just hooked it all up. And we'll see if we get any audio once the tubes warm up here. You'll see that meter come down. There it is, as she warms up. Yeah, I'm not hearing any hiss. And the S meter is moved up to 10/9 and just sitting there. Oh wait. Yeah, well, normal. No, it's still drifting down. Still warming up. 7. But I'm not getting any audio. Well, maybe I hear a little hum. A little scratchiness, just a touch from the pot. I suspect the audio amp is working. So let's introduce a signal. And we'll turn on the calibrator. Oh! Okay, I see we got some S meter action, and I heard it. Okay, I'm going to put the microphone near the radio, or near the speaker. So as you can hear, hopefully, we do have audio, but it's pretty low. I've got that volume control. Yeah, volume control still works, but I've got that all the way up. Okay. Yep, alrighty. Well, so we don't have audio, or we have very weak audio. Let's go have a look at the schematic. Here's the relevant portion of the schematic for the Tempo 1. This is the audio output stage here. We've got the audio power amplifier and the audio driver. This is the transformer, audio transformer that goes out to the speaker and the headphones with an 8 ohm secondary. Let's see, here's the AF gain control here. That's the volume control. And this is the automatic noise limiter switch, which is on the volume control. When you pull the volume control out, this switch flips and engages this noise limiter circuitry here, which is basically a little capacitive delay that kind of cuts down on the little pops of the individual static crackles coming through. And then this would be the detector, where your audio detection happens over here. Now, I heard a little bit of audio coming through the receiver. So it was very faint, very weak. So that means we've probably got a good chain. We've got good connection from the audio coming through the gain control to the power amp. Something is just weak. So I'm going to test the power amp stage, and if we've got good audio there, I'm going to work backwards and check the detector. And that we should probably find the problem somewhere in this circuitry here. Somewhere between the detector and the audio amp stage is where we're going to find the problem, I'm pretty sure. Since we're receiving a signal and we're hearing it just faintly, everything up the stream from this detector is probably working okay. So let's go test the audio amplifier. Okay, I've gone ahead and taken the cover off the radio, and we're going to test the audio stage. Now, being that we heard the calibrator signal, I have some known goods already, some known good conditions. We know the local oscillator and the mixer are working because it's processing the RF. We have a fairly good idea that the IF stages are probably working because we're getting some signal through. We know the beat frequency oscillator is working because I could hear the tone from the beat frequency oscillator mixing with the received carrier. So we know some of the stages of the receiver are good. What we don't know about is the audio amplifier. It could be weak. And the detector stage, which could be very weak. If you'll recall from the schematic, the detector, which is, well, it's the tube on the other side, but it's right here, feeds the audio gain control, the volume control, right over here. And that then feeds a signal into the audio preamp and audio power amplifiers, which are two stages of the same tube. There's one tube that has two triodes in it, or pentodes, or whatever. There's two stages in that tube. One of them is used as the audio preamplifier, one's the power amplifier. But the volume control feeds signal to the audio preamplifier from the detector. So what I need to do is I need to inject a signal into the volume control. Now I'm going to turn the radio on, and we'll wait for it to warm up. Now this old tube gear, I'm sure I've mentioned this before and others have also mentioned it. You've got voltages in here of 250 volts and 800 volts down here around the finals. So you really want to be cautious and know what you're doing if you're working on this tube gear, because the voltages in here can kill you. Okay, so bear that in mind. Okay, I'm starting to hear a little hum from the speakers, so the tubes have warmed up. I need to inject a signal right here into the volume control. The simplest way to inject a signal, you can have a signal generator, which is an oscillator, and use that to inject a nice tone. I'm going to take the lead from my DVM, and I'm just going to touch the volume control center wiper. Now the wire is going to pick up 60 cycle noise from the overhead lights and the other equipment on the bench, and we should hear a bzz, bzz sound when I touch that, so let's see. I'd say the audio stage is working. We turn that volume down and touch that center wiper. Yeah. Okay. Well, good. Now we know the audio amplifier stage is working, because that was definitely plenty of audio power. Well, that's pointing me now down to the detector and the circuitry between it. Now, it could still be a problem in the IF stages. We could be losing amplification somewhere along there. But I would suspect that if some of the IF stages were working, we would hear hiss. We'd have a good solid hiss coming from that detector through the audio amp. Since there's nothing getting amplified, we're not getting any signal out of that detector at all. I'm suspecting that detector. I borrowed a tube tester this morning, and I'm going to go ahead and test, starting with that detector, all the tubes in the radio. We might as well, as long as I got the tester, we might as well check them all, but I'm going to check that detector first and see what's going on there. So let me get the tube tester over here, and I'll show you how to use the tube tester. All right, this is a Hickok 532 tube tester that I have borrowed. The way a tube tester works is they've got sockets for every type of tube. Inside of here is a power supply, multi-tap transformer, and a big wiring harness, a bunch of switches. And these switches let you set the wires on the tube sockets to where the anode, cathode, and grids are. And then you've got test buttons where you can push the button and it will feed voltage to the tube. And if the tube is passing voltage like it should, the meter deflects. And if it deflects up into the good range, the tube is good. So this is the detector tube out of the Tempo 1. It's a 12AX7A. It fits in that socket. And then we go to the chart. Now, these early tube testers had a scroll in here of settings, and you'd use this knob to roll through the settings, but that's broken on this one. The owner has an unrolled scroll right there with all the different tube models and all the switch settings listed. So this is a 12AX7A. Here we are, 12AX7. And let's see, 12.6 volt filament. Okay, we're set to 12.6 volts. And then we set these dials across the top, EV7608. 76080. All right, then we got a bias voltage. We set this to 12. And what's that? English. I'm not sure what that stands for. Must be a calibration on the meter, I bet. 58. Okay, 58. All right, now we'll power the thing on. Light comes on. Now it's heating up the tube. We got to wait for a moment for the tube to warm up, and then we will push P4. The diagram says we push P4 to test the tube's gain. Now what'll happen is that meter will deflect. Let's see if we... Well, all right. It's weak, but it's in the good range. I don't know if you can see that. It came up just into the good range, so it's weak. Now this tube is a dual triode, meaning there's two sections in it. In fact, in the radio, this tube does dual duty. It's the detector and it's the ALC, either of which could be causing a problem. So let's set it for the second triode. EV2 103 0. Okay, everything else is the same, and we push P4 again. A little bit better, but still in the good range. Okay, so it's the problem with the low audio is not our detector tube. So that's how you use a tube tester. I'm going to go through the radio and test every tube. I'm going to go through the IF section next. It's got to be either in the IF section or it's got to be another component failure in or around the IF section or the detector, since we know the audio amp's working. So anyway, I'm going to test the rest of the tubes in the radio, and then I'll get back to you and let you know what I found out. Well, testing tubes was not fruitful. All the tubes tested okay. So I started poking around, thinking more and more about the audio path. And if you'll recall from the schematic, and I'll pull it back up again here, the automatic noise limiter switch, the audio going to the AF gain comes through the center of that switch, and that switches it between direct audio tap from the detector to going through that diode and resistive capacitive filter there that would filter out noise spikes. So I hadn't checked that A&L switch. Now that switch is right here, and it's activated by pulling the volume knob out. It's a rotary switch, a little arm here switches it. And it has two sets of contacts. There's a center and on one way and the other way, and then at the bottom there's a center in one way and the other way. They're using the bottom set of contacts. Now I've got my meter on continuity. So if I put my meter on that center pin at the bottom, and we check it to the outer pin, nothing. Okay, and we'll go from the center pin to the other side. Nothing. It's open. We got a bad switch. How about that? I'll pull the switch and check it again, both ways. Open. And open. So, yeah, we got a bad switch. Isn't that something? Now, fortunately, this switch has built-in redundancy because up here on top there are 3 contacts. These are unused. Let's test these. Oh yeah, okay, they're good. So what I'm going to do is I'm going to move the connections from the bottom set of contacts to these top set of contacts, and we'll just use the other side of the switch, and that'll bring the audio back. So I'm going to heat the soldering iron up, and we'll take care of that, and that's going to solve this problem. Okay, We have now wired to the alternate set of unused contacts on this switch. It also let me shorten that wire that brings the audio over to the pot. Not that that's going to make a big difference, but yeah, shorter runs are always better. Less chance of RF and interference. So the only thing left to do now is to hook it all back up and see if it works. I'm so confident I'm going to put the cover back on before I do so. So be right back. Okay, we're all back together. Plugged in, I hooked up the antenna. Here we go. I hate waiting for the tubes to warm up. Come on, baby, give me some audio. Hey! The automatic noise limiter actually makes a little bit of a difference. Yeah, I guess I'll give the owner a call, tell him to come get his radio. It's living yet again. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.